right, let me just make sure that we are streaming here. And I think we're good. All right, so welcome back. Thanks for joining again. Good morning, good afternoon, and good evening, wherever you're tuning in from. So today is going to be the first day of our new project. So if you are new to the stream or if you haven't been following along, we in the previous project that we were working on was trying to use ML.NET and deep learning to perform static malware analysis. So what we did was we took raw binary files and we took the bytes, and what we did was we encoded those bytes into an image. So now to the human eye, that image or the encoded bits, they didn't necessarily look like anything. They just looked like noise, like static. But that static perhaps could have meant something for the computer, right? So or for a deep learning algorithm, and that's exactly what we did. So we trained a deep learning model, image classification model, to try to categorize malware into one of 9 families. And what we did was we ended up submitting this. This was part of a Kaggle competition. Was actually took place 5 years ago. So we used that data set to train our machine learning model, and we could still submit it. Of course, we couldn't win a prize for it anymore because, again, the competition ended 5 years ago. But what we did do was we just took for comparison just to see how well we had performed, and it wasn't terrible. Um, we I think it was 250 something or 230 something, placed 230 something or 250 something out of 300. I believe 27 or 357. I forget the exact numbers, but we placed towards the bottom. But considering it was just one time, we didn't optimize anything. We didn't try different architectures. I think we just did ResNet. I consider that pretty good, right? We weren't last, so I guess I would think that counts for something. Um, but yeah, so I was pretty happy. I was pretty excited to get that working. Again, I wasn't too happy with the performance, but again, there's many things that we could do to continue to improve that. But for the time being, what I want to do is we sort of achieve the goal of learning. Could we do this? Could we leverage F sharp? Could we leverage ML.NET and the image classification trainer within ML.NET to build this solution, right? And we successfully did that. So I think, sort of, in terms of checking it off the list, I think we achieved what we set out to do. Now, like I said, of course, there's many ways that this could be improved. Um, we can, like I said, try other architectures. We weren't encoding the images the right way. There's a lot of things, right, that we have to consider and take into account. But again, I'm pretty happy that we were able to sort of get that working end to end. At some point I do want to go back and clean that up a bit, but by no means do I, expect you folks to sit on stream with me, trying to clean that up and add a README so that anybody who may be new to that project, is able to sort of follow along or set it up on their own. So I'll do that on my own time. Um, and so with that being said, today we're going to be starting a new project. But before we do that, let's kind of walk through some of these links here, from the F Sharp Weekly. All right. So if we take a look at some of the videos and slides, there's a lot of interesting things. There was a blog post from Philip, who is the PM for F Sharp. Let's see if I can open this up. So basically, talking about the improvements, the latest improvements, and the latest additions to the F Sharp tooling and F Sharp 5. One of the neat things that I think is going to be really interesting for us, it's going to be these two things, right? Being able to, we already know that we can use Jupyter with .NET. more specifically with F Sharp as well. But having the ability to sort of parameterize. Um, Actually, no, that's not it. The ability to work in another environment. I always get these confused. Interact and Paper Mill. So Paper Mill is this tool that allows you to uh, it allows you to essentially parameterize your notebooks, right? So you're able to sort of run them as part of batch jobs or whatever. And Interact is basically kind of like this program environment for notebooks, similar to something like Jupyter Lab, right? So there's that. There's this other neat thing, which is the ability to run Jupyter notebooks inside of VS Code, right? So that's really cool in terms of adding references. Right now, you should be able to. Now this has been around for a while, but again, there's improvements to this, right? So it keeps getting better and better. The ability to pound R and provide and tell it, hey, load this NuGet package, install it, and load it into my project. That's really neat. Interop, computation expressions. Let's see, finishing up name of. Yep, there it is. So this is a bit of a sneak peek into F Sharp and VS Code Notebook. So if you've worked with Python in the past, you may be familiar that you're able to with the fact that you're able to sort of inside of Visual Studio Code, you're able to run and sort of debug your Jupyter notebooks, right? Now that again, .NET Interactive, which is the kernel that allows you to run .NET code inside of Jupyter notebooks, that's fairly new, right? I mean, IF Sharp had been around for a while, but sort of as a C Sharp, F Sharp, PowerShell cohesive sort of product, that bit is fairly new, right? And the functionality of getting this to work with VS Code, it wasn't there yet, but it will soon be possible. There's a lot of work being done, right? It's the first preview of it, so yeah, feel free to definitely go and check it out and try it out and provide feedback for the team if you have any. Okay, so let's see what else is there. There's this really cool playlist on YouTube on rapid data analysis, and it walks through all the way from getting the data. Hey, how's it going? Um, so it walks you through all the way of the process of getting the data, building an API for it, going ahead and launching. Right. So getting the data and sort of cleaning the data and doing things like that. The second one, it talks about how you can then build a web application around that, like a web API for you to access the data. And then this part talks about how to build a user interface so you can show off really nice charts, and it's all done in F Sharp, right? So using I believe it uses Saturn, right? So that's cool. Definitely check it out. This one we kind of talked about a bit yesterday. Our friend John here, he set up a really nice interview with some of the folks on the ML.NET team and just kind of talked through different things around the ML.NET, the ecosystem, where it's headed, things like that. And yeah, so I'm gonna paste this into the chat, and you can sort of go through it at your own leisure. But now we are going to go into the project, and I'm going to kind of talk a little bit about the project that we're going to be working on. For honestly, I don't know. I don't have any. So in our previous project, we had a sort of a defined goal, right? There was this paper, there was white paper, and we wanted to implement this paper. See, can we implement, can we build a system similar to what this white paper says, right? And in our case, it was using deep learning, image classification for doing static malware analysis. So we had a pretty clear cut and defined goal of what we were trying to achieve. All right, we're trying to build this model to perform this task. And we kind of had some guidance, right? The paper kind of told us how we might want to achieve that. So that was great. This project is going to be a little bit different. We have no defined goal. Of course, if you folks have any ideas or things that you would like to see, we can work them in. But there's no, there's no real sort of point that we can, or goalpost that we can sort of point to and say, okay, that's the goal, or that's the end of this project, right? And what we're going to be working with is this tool, system, framework. I don't even know what to call it. It's called Kubeflow. And Kubeflow is a project, an open source project. It actually, I believe in March of 2020, some parts of it reached general availability, or reached version 1.0. Some of the things are still in beta, which is okay, but there are plans to have those beta pieces graduate to version 1.0. And again, it's an open source project. It is, I believe, it came out of Google. And what it is it's this framework that allows you to train, test, deploy, basically manage a lot of the work and processes that are typically involved with machine learning. Now, one note of distinction that I like to make is I wouldn't want this to be confused with MLflow or with the other project that our friend Alexander is working on, MLOps.net, right? So those are strictly focused on metadata management and artifact management as it pertains to models, right? Trained models. Kubeflow is a little bit different in the sense that while there is a metadata component and while there is an artifact piece, it's only one part of Kubeflow. There's so many more. Again, there's the serving component. There is the sort of the training and pipeline building component. So while there are some similarities, Kubeflow is a little bit different, and we're kind of going to, play buzzword bingo here with everything, right? So what Kubeflow allows you to do is it allows you to, or the goal of it, at least from what I've read, the goal of it is it allows you to build composable, portable, and scalable machine learning systems, right? And the way that it believes it can do that is through containers, right? So containers, they are composable, right? You can mix and match your containers. You can sort of deploy them as separate microservices, right? You can have one container running one service. You can have another container running another service, right? And you can compose those, right? You can take a service down, you can replace it with a completely different implementation, and containers allow you to do that, right? It's portable, again, along the same lines of containers being portable, in the sense that that you can basically run it. If you have Docker installed or any sort of container environment, right? The idea is if it runs on your container environment, it will run anywhere, right? So if you get your image running, it will run anywhere, Linux, Mac, wherever, right? Whatever system, underlying system you're working on. And then the scalable piece is, again, right, because you're able to create and manage many of these containers at once, right? There's a scalability piece that you can just sort of spin up or tear down these services, these processes as you please, right, or as needed. And that's great, right? So containers are a step in the right direction towards achieving this goal of composability, portability, and scalability. But you need something to manage these containers, right? And that's kind of where Kubernetes comes along, right? So Kubeflow is exactly that. It's this machine learning, there it is, toolkit. Didn't think of that one, but toolkit built on top of Kubernetes, right? So there's, like I said, there's different components. So if we take a quick look here at some of the components of Kubeflow, there's a UI that allows you to sort of manage your servers, your services, and things like that. So, right, so you get a nice UI. You're not necessarily restricted to working in the command line, which a lot of times you may have to do for Kubernetes. And okay, so there's a dashboard that allows you to manage pipelines, Katib, which I think Katib is so pipelines is exactly what it sounds like. It's a way for you to build end-to-end sort of workflows, right, for machine learning. There's Katib, and Katib, from my understanding, is something that allows you to perform hyperparameter tuning, right? So it's something alike to something along the likes of like automated ML, right? So I don't know how much use we're going to be making out of Katib, but again, it's something to consider as well. There's a notebooks component which allows you to, what it sounds like, it allows you to host notebooks inside of this Kubernetes environment, right? Let's see what else is there. There's an artifact store, which is kind of like what I was talking about earlier, right? You're able to sort of track metadata as well as the artifacts themselves, right? So that means models and things like that. And then there's, you can manage contributors. So if you have other people that you want working inside of your environment, right, that's the really nice thing that it allows you to sort of share resources with them, which is great. There's a training component, which I don't know how much use we might get out of it, right? So if you wanted to train models with Kubeflow, it seems like these might be the only environments that are made available to us, right? So TensorFlow, PyTorch, a lot of the popular, right? Some of the usual suspects. So I don't know how much we were going to be getting out of training with Kubeflow. But because we can build pipelines and our pipeline can include training steps, if we take a quick look at pipelines, right? One of the nice things that you're able to do is I think you're able to, okay. I thought I was in the pipeline section. One of the nice things that I think we're able to do is I think we're able to plug in custom. There you go. See, pipeline components is a self-contained set of user code packaged as a Docker image. And because it's packaged as a Docker image, we can put whatever we want inside of it, right? Or at least that's the idea, right? And the component can be responsible for data processing, data transformation, model training, and so on. So I think pipelines might be the thing that we're going to get more use out of as opposed to the training components that Kubeflow gives us, right? And of course, we're going to also want to make use of Jupyter notebooks, right? We might be building our models inside of Jupyter notebooks, right? So yeah, so there's a lot of components that we can use here, and again, the fact that we can mix and match, right? So you can also imagine, right? For example, there's some components or there's some libraries. Let's say like for data pre-processing, right? Some components for building a model, we may not be able to find them in .NET, right? Maybe the library's not there or whatever. But because again, it's composable, we could get the pre-processing piece done in, say, Python. And we can save that to a flat file, the pre-processed data to a flat file that we can then just load into a .NET sort of pipeline into an iData view and continue processing and training our models that way, right? So there's a lot of really nice things to like. At least, I haven't worked with Kubeflow, but I've been, greatly interested in it. So that's what we're going to do on stream. We're going to go ahead and we're going to explore Kubeflow. I think this, for the first couple of days, it's been a while since I've set up Kubernetes. So we're going to walk through the initial setup, trying to get our instances or Kubernetes environment set up. We are then going to try to set up Jupyter notebooks so that we can begin playing with data and exploring our data. And then we're going to try to work with building pipelines and leveraging some of the metadata components of Kubeflow, right? So we'll see how we do. But yeah, so that's the plan. There's, like I said, in terms of the goal, I guess one of the goals here is, number one is to learn a little bit Kubernetes a little bit better. Number two is to learn about Kubeflow a little bit better and what sort of systems are out there that can help us build production ready and scalable sort of machine learning workflows and projects. Um, and 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 yeah, so that's kind of going to be the goals. The What's not going to be a goal is we're not necessarily going to be care about which type of model, right? Like for our purposes, I think we can, for the sake of simplicity, and just to make sure, like, hey, is this thing working? We might want to consider doing something as simple as like, or as sort of, like not simple, but something along the lines of Iris, right? So Iris isn't terribly exciting, but it's going to allow us to test out and learn. Okay, well, here's how pipelines fit together. Here's how you can build a pipeline, so on and so forth, right? So that's kind of what we're going to be working towards. And yeah, so with that being said, I hope you folks are interested. I hope you folks and if you have experience with Kubeflow, let me know, and would love to get your feedback, and of course your input on this journey. So yeah, I'm like I said, I'm excited, and yeah, let's get started. So there's many different ways to, from what I've seen, of installing Kubeflow. Um, it says that you need to have some sort of knowledge about Kubernetes and customize. If you plan, review these Kubernetes system requirements. Now, I don't know if it's strictly necessary for us to set up a cluster, uh, in part because it can get expensive, right? And I am not looking to get like a few hundred. Well, actually, you know what? Let's explore. Let's see. I think it's AKS. Azure AKS. Let's see what it would cost us, more or less. Azure Kubernetes Service. Let's see here. Is the video coming through okay? I think I may notice a bit of a lag, so just want to make sure that the video is coming through okay. So let's take a look at pricing here. Awesome, thank you for letting me know that it's coming through okay. Okay, so let's see what the AKS pricing is, and I suspect that it's not. Okay, so Central US is not available. What about East US? Okay. Let's see. Financially backed. Okay. Kubernetes API servers, clusters, availability zones. Okay. So it's 10 cents per cluster. Oh, option to add uptime. Okay. No, that's not. I don't think that's true. Only pay for the virtual machine instances, storage, networking resources consumed by your Kubernetes cluster. Okay. It's fair. But so you're saying that if I want, I can have a bunch of really, really affordable, sort of low end machines and still. Okay. There's no charge for cluster management, and we want what? East US. That's fine. So I want, well, I don't care about the uptime SLA. I do care. So I think it's typically recommended that you have three. Um, but I am not looking to pay. And that's using that as well, right? So using the D2. Perhaps I don't want any of the Ds. I think I would be okay with one of the Fs. Where's the Fs? F, 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 F. There we go. 0.09. I think this is the one we had last time. Yep, this is the one we got last time. Oof. Really? Still $200. Plus, we gotta consider the discs. Um, yeah, I mean, I get that it's gonna, in terms of the management, it's gonna save me a little bit, right? So a few headaches rather than me wiring everything up. Um, but this is significant. I'm not looking to spend that much money. Let's see here. Okay. So let's try something. What are we gonna try? So, well, first of all, let's probably go back to Azure. This is something that I completely forgot to do last time, which was to shut down my machine. So, for fun, we can maybe take a look at what that cost us. And while we're at it, okay, so let's see. Let's go installing. Limit to single node cluster. I think this might be the option that we want to go with, especially because we're going to be just doing testing. We don't necessarily care about. So while we want Kubeflow to be scalable, at the same time, we don't necessarily care too much about the scaling capabilities, right? We're going to be using it ourselves, and we're just going to be testing the features and functionality of Kubeflow. We won't necessarily be worried about like, oh, we got 100 new users, therefore we need to scale our services, right? So I think this is our best approach to single node deployment, right? And to do that, I think, let's see, Kubernetes installation. Deployment to instruction for installing Kubeflow to an existing Kubernetes cluster. We don't have an existing cluster, so this is not what we want. Workstation installation, right, for installing Kubeflow on a workstation or server. Okay, so I think that this is the one that we want. And I think we might even be able to essentially fit everything in inside of the server that we had. So let's see, Linux server. For Linux systems, you have options for server, physical, virtual. The server options, okay, Linux server. Kubeflow, this is Linux hosts and virtual machines such as VMs, OpenStack, VMware. Okay, fine. So Micro K8 runs natively on most. Follow the installation for Kubernetes setup, enable. Okay. If you already have Ubuntu that supports snaps, I think we do. I think 1804 supports snaps, so fine. Okay, if you have a Linux system already, or you would like to confine your Kubeflow to a disposable machine, I don't really care about the disposable machine piece. The only thing that I'd be concerned about here is localhost as the IP in your browser. Otherwise, if you use multipass, you can get IP. The only thing that I'd be concerned about here is if I would somebody be able to access my VM? Well, not the VM, but Kubeflow once I have it set up. That's a concern. Let's see. So this seems like the way that we want to go. But is that right? Let's see here. I wonder if there's any like minimum hardware requirements. Kubeflow on Linux. Yeah, micro K8s. All right, so just for the sake of it here, let's bring this here. Okay. Cost alerts, cost analysis. I think I might just keep this going. Well, that's going. Let's try to load our. Okay, so we're at $94. And storage is a big part of that. Which makes sense. I think we had like about close to 500 gigs on that drive that we set up. So it kind of makes sense. Let's see. So let's see. Forecast 145. Yeah, that's pretty. It's pretty high. All right. Let's see here. Okay. All right, so here we are back in our trusty VM. Let's see, how much storage space do we still have? We still got 20 gigs. I think micro K8s should take less than that. But yeah, so let's try it. But before we do that, let's update our system. So how are you guys this weekend? Anything fun? Okay, this is done. Okay. Get rid of any old packages. All right, cool. So now that we have that set up, let's go ahead and let's see if we can install this. Follow the installation guide. Okay, so set up micro K8s that support snaps. You can instance of using micro Ks. You can jump into the Kubeflow section below. Okay, if you don't have a, okay, yeah. So we do have one that does. So one install. So snap. Let me see. If I remember correctly, Kubeflow Ubuntu. I think that I saw a guide somewhere else, like here, and I wonder if this guide is any different. Let's see. Try Kubeflow. Now we don't have a GPU. Okay, so it's the same thing here. To enable features cluster with the following commands: DNS storage. Okay, so let's go through this. Whoops, not that. Okay, let's see here. Okay. So that's on our clipboard, and now Why does it keep... I know I copied it over. Let's see. Okay, there we go. All right. Let's see how much of it takes from us. So I don't know. I have to do a little bit of investigation myself and looking into it some more. But so it seems like Ubuntu has chosen to push for snaps a little bit more, right? And within the Unix community, it seems like some people may be against that. I mean, it looks like it's pretty easy to install these snaps, right? But I'm not quite sure what the pushback is. But you know, Linux Mint, right? So that's another distribution came out and they said, yeah, we're dropping support for snaps. So yeah, interesting. I don't like I said, either way, I don't know what's better, or let's see, insufficient permissions. What? So I need to sudo. You can either try adding with sudo or add the user Azure user to the microcades. Okay. Sudo user mod ag micro k8 Azure user. And sudo user dot q. Okay. Okay. So what I was doing here was, so now that micro k8s. Oh, there it is. Oh, new group will view this. Okay, so let's log out. Let's log back in. Okay, cool. All right, so we are doing stuff here. Is not enable access that was using default token retrieved. Enable setup, you need to create a user with restricted permissions as shown. Okay, not now, Alyssa. Canonical their own thing again and disregarding the rest of the community. There are a couple of different approaches around. Same deal as with display service, I suppose. Yeah, I think, yeah. I think you got it spot on. That, yeah, it's Canonical doing. Yeah, I mean, yeah, it's interesting, right? I mean, it's like these snaps make it easier to do stuff, as we have seen, right? That being said, though, it's not much easier than, you know, using apt-get and being able to control and be able to see what is being put into your system. So I don't know. Yeah. Yeah. But it's nice, right? It's nice. So it's nice that there are different approaches, right? That there's a community and people are passionate, like, hey, you know, maybe this is not the way that we should go. And there's options. So that's one of the nice things about you know, Unix, Linux distributions, right? It's like, if this distribution doesn't meet your needs or it's too bloated or whatever it is, right? There's choice, which is nice. Choice is always good. Okay, so I did stuff. If RBAC role-based access in RBAC enable setup, I don't think I have an. I'm gonna save this for now. I don't know what it means at the moment, but let's save it for now. But I think what this is telling us is kind of like it's trying to keep us from dashboard. Okay. it's gonna keep that thing from happening, right? Which is like essentially that anybody can access our cluster. So now enable Kubeflow. 14 gigs of memory. We barely have 4. Um, yep. This is what we're gonna want. Um, okay, so we did this. Okay, there's all these nice things getting set up for us. Deploying Kubeflow. Ooh, nope. I don't want that. So I just read that after installing Kubeflow, an IP address and credentials will be prompted on your terminal. You simply need to access the IP address provided in your browser. So the IP is fine. The credentials, I don't want those showing on screen. So you'll just have to stare at this in the meantime. Let's see. Okay, so once we're done installing it, what do we want to do? Components of Kubeflow. So one of them that we definitely want to access is this dashboard, right? We want to see kind of what it looks like, get a sense of what we can and can't do with it. Let's see, what is this registration flow? This guy, Kubeflow users who are logging in Kubeflow for the first time. The user may be a person who deployed Kubeflow. Okay. You will need to create a namespace when you first log into Kubeflow. Namespaces are sometimes called profiles or work groups. Okay. Cool. Next steps. Set up a Jupyter. Okay. We'll see here. But yeah, so this is exactly the next step that I want. So for the next step, I do want to set up notebooks. And I want to get .NET Interactive running on Kubeflow. So once it finishes. Oh, so last time, I think, when did I see it? So this is really cool thing. What's it called? Microsoft SandDance. So this really cool plotting library from Microsoft Research called SandDance. SandDance. It's very neat, and I think it uses. Yeah, there you go. It uses Vega, and so it uses these things, right, for the visualizations. And if we go to the SandDance website, I think it's JS based. Yeah, but so check it out. Check out what you could do. That's really cool. So I think it's JavaScript based. Like you can use it with React, you can use it with Vue. This is a UI. But I think you can just use the core. Now, what would be really interesting is now you can do this, right? And because it's just JavaScript, could we get something like this working with could we get this working with Jupyter notebooks? And I don't know. I don't know the answer to that. But worth a shot. Worth a try. All right. Maybe we can use some of the Fable functionality. So for .NET, it depends. So if you're doing open source, plotting, like if you want to do open source and free, xplot is really nice. um, and you can do plotting. Yeah, native plotting, right? You can use xplot or xplot plotly. And let me see. So you would use something like this, right? I'll paste this into the chat. And this is really nice, and it's actually I think what Jupyter Notebooks uses. Or you can definitely use this with Jupyter Notebook. Oh wow, 8 months ago. I thought that maybe there was like a more recent um, release, but I guess not. Anyway, so you could probably use this. If you want a commercial version of it, there's a bunch of vendors that provide pretty nice, that provide nice visualizations, right? Like Telerik and others. But again, you have to pay for those. So XPlot Plotly is actually really good. It's really good. Let's see if we can go to the project side to kind of see what's going on here. But I could imagine. So if we're doing it in Jupyter Notebooks, we could. I don't know if we could use SandDance. But if we're doing like web visualizations, right? So very similar to what I was talking about before here, like with F# Weekly, right? There is this rapid data analysis with F#. And I think what this did, I don't remember if there was a chart that was added. I'll have to take a look. Oh, there were charts that were generated. So if you're doing this on the web, right? One of the things that you could do, so on the C#, and you could do the JS interop and build and actually get this working with Blazor, right? So you can use JS interop. You can call into your JavaScript functions to generate these plots for you, and you could potentially do that with WASM, Blazor WASM. On the F# side of things, you could probably do it with Bolero as well. I don't quite know too much about Bolero, but my understanding is that in terms of features and how you would go about using Bolero, it's the features are pretty much the same as those of Blazor. So again, you can have that JS interop piece. So that's how I would go about it. If it's just for presentation purposes, I think that's how it could work. If you're working inside of a Jupyter Notebook, I don't know if you're able to do this. Now I know that .NET Interactive is polyglot, and you can definitely mix and match. You can add HTML, you can add JavaScript, but I don't know if you'd be able to hook into this. So yeah. And Kubeflow is still deploying. So yeah. But yeah, I mean, I just thought that you folks would find this interesting. There's actually a VS Code extension for it, which is really nice. If we go ahead and try it on the web. I suspect we might have to bump up or change our VM, because it might not have enough resources to deploy Kubeflow to, but we'll see. Let me actually get rid of some of these. Oh, and yeah, let me paste the link to SandDance in the chat so that you folks can check it out if you want. Let's see, SandDance. Wow. So let me get rid of some of these tabs that are not adding anything. So we chose to forgo again that setting up a Kubernetes cluster. on Azure. Part of it is because we're going to be using this for quite some time, and I don't want to rack up the cost that the cluster would incur. So we are instead just doing it on a single cluster or a single node cluster, which I think should be okay for our purposes, or at least for now. If we do need to scale up, we'll do that accordingly. Okay, so let's see here while that's loading. Set up your notebooks. Getting started with Jupyter Notebooks on Kubeflow. Services for spawning and managing Jupyter Notebooks. Okay, Kubeflow Notebook servers. You can create a new server, connect, upload. Notebook servers. You need to create a namespace. Okay, create a new server, namespace. Okay, so this is the cool thing, right? So we can add a custom image. Now, this custom image, what we could do is, I don't know if .NET Interactive has a public image on their on like Docker Hub or Azure Container Registry. But if they don't, we can easily create an image for ourselves that we can host inside of our Kubernetes, inside of our Docker Hub or my Docker Hub, and then we're going to use that to build the .NET Interactive image that we're going to use for this server. Okay, indicate the following choices. Interesting. The persistent volume ensures that you can retain data even if you destroy your notebook server. Okay, that's good. We definitely want that. Oh, I should have started this in like a TMUX session. Now I can't see how, like, what's going on with my system unless I open up a new terminal. All right, let's see. No. All right, so let's see what's going on here. HTOP. So it's actually not all being used. I mean, I can see a lot of different services from micro Kubernetes, but I don't see, it's not, the utilization isn't as high. It means high, but not that high. All right, let's see, quit. All right. So multi-user isolation. See, create a custom Jupyter image. This is exactly what we're looking for. Guide tells you how to configure server in Kubeflow. It must meet requirements. Kubeflow controller, which manages the lifecycle. Docker run. Okay. That's cool, I guess. Let's see what's this troubleshooting guide. Okay, first make sure P is user bounded when Jupyter Notebooks. Okay, persistent volumes, persistent volume claims. Okay, cool. What is this? Fairing. Process of building, training, and deploying machine learning, training jobs, hybrid cloud. Oh, hybrid clouds. Okay. Let's see. This load. Okay, there we go. So what we can do is there's 25,000 rows, and this is voting data, I think. There's the bars. That doesn't tell us anything. What is this? Stacks. Oh, cool. Let's see. Median age. What were the median? That's not right. So I'm gonna say that this is like voting data, and I'm not sure what the source is, but I'm gonna say this is wrong. I don't think you could vote at age 12. I don't think so. So that seems a bit of odd. Okay, let's see, income. Oh, cool, and you can look up like both numerical and categorical data on here. Okay. That is, oh, it's like right, really? Oh, this is one of the red. Oh, it's like right around my area. Guttenberg, West New York, Richfield Park. Interesting. Hoboken City. Okay. Never heard of Hoboken City. But yeah, it is really cool. Let's see. Is my thing almost done? Ooh, almost. Waiting for operator. So Kubeflow was deployed, waiting for operator pods to become ready. Almost there. I do hope that it gets a little bit more exciting once this thing deploys, because right now there's really nothing happening. And I'm here just filling time with this. Let's see what else. Median home value. So when we do this one here, I would expect, yeah, there we go. How can I sort of shift it though? Like I'm trying to, there we go. Okay. And this makes sense that house prices are ridiculous here in the East Coast. But I'm actually surprised that it's not as high here in the West Coast. Or I wonder if what this is trying to show is like the different counties. Like each one of these little blocks here is, there are the counties. Maybe. Not exactly sure. Where is this? Colorado. Home prices are pretty high. Washington, they're pretty high. Texas, they're low. Relatively low. Let's see. What's the median home valued? Almost $1 million in Westover Hills. Is that, what is that? Is that a whale or a? Is that supposed to? It's like really small. It's kind of hard to tell. Oh, whoa! What happened? Okay, let's see. This thing's still going, and I have no idea what happened here. Oh. What happened to my colors? Did my colors go away? Oh, Kubernetes. Yeah, yeah, yeah. Yeah. I don't know how they. I remember reading some time ago how they came up with the whole ship and nautical theme, but I forget exactly. You can add dark mode. Oh, very fancy. I just wish I knew where the colors went though. Let's see. Yep, that's fine. Color by income. Oh, there it is. It's back. That was odd. Let's see. What am I supposed? What do I want to see? Chart color. Blue and orange. Fancy. Quantize. What is this? Snapshots. This is very cool. Create snapshot. Yeah, I'll probably keep playing with this at some point. If we end up building like some sort of layer, maybe when we deploy our models, whatever it is that we end up building, maybe I'll play with this. I'll try to get this integrated. Um, are we done? No. Okay, almost. Let's see what else is going on. High performance requests. So I this past weekend I decided to give what's it called, Westworld, a try. I had never watched it before, and I dipped my toes into it this weekend, and it's pretty good. It's pretty good. I'm not gonna lie. Almost done with like season one, so that's nice, I guess. It probably shows that I have no life, but that's okay too. This thing's still going. Yes. Okay, localhost your ambassador port. So once this is done, let's see. Once this is done, I'll try to log in, and then I think that we'll call it a day after that. So let's just first make sure that we have our Kubernetes cluster deployed. Once it's deployed, just want to make sure that we're able to log in. And once we are logged in, we're going to call it a day until Wednesday, where I might do a longer stream. I might do a bit of a longer stream where we'll explore. I mean, I'm already going like about an hour and a half now, so maybe 2 hours, maybe a little bit longer on Wednesday, where we're going to or we're going to try to set up. The first thing that we're going to try to do is we're going to try to build an image for .NET Interactive, so that then we can run it as a notebook server inside of Kubeflow, right? So that's assuming that this all deploys correctly. That's kind of what we're going to try to do. The other thing, I don't know if we talked about last time, but at some point, what I'd like to also look into. So Kubernetes, I wonder if you can install. Well, why would you want to install Kubeflow on an edge device? I don't know. Let's find out. Kubeflow Raspberry Pi. I'm pretty sure you could do it because you could build a Kubernetes cluster with a Raspberry Pi with K3s, I think it's called. Um, yeah, with K3s. And if you can build your cluster with K3s, then you could probably deploy to a Raspberry Pi with Kubeflow. Mm, I don't know. Interesting idea though. Maybe something later on we might want to try on stream. I've ran into another old Raspberry Pi that I have lying around, so I might use it. I think it's still like a Raspberry Pi 2. We're already on 4 plus. So this one's a 2. Okay, let's see here. Let's see what kind of samples they have. Okay, MNIST. Might want to do MNIST. Although, let's see. So MNIST. Here's the model, notebook setup. TensorFlow. They're using TensorFlow here. And I think that this is for Google Compute platform. What's it look like for? Oh, vanilla. I want vanilla. Okay, so pushing to Docker Hub. Let's see. Prepare the model. The example guys usually taking an example TensorFlow model, modifying it to support distributed training. Yeah, we're not going to do distributed training. Serving the results model using TF serving. Yeah, so this is another really cool thing, right? That's one of the things that we didn't go over, which was the deployment piece. Let's see. Documentation. Components. Tools for serving. Okay. So out of the box, Qflow has a lot of ways of serving. There's KF serving, which I think is the most generic one. It's still in beta, but again, I'm pretty sure that this is one of the ways that they're going to eventually how can I say this? They're going to eventually graduate it to version 1.0, right, or to a stable version. And KF serving, right? You basically get your model assets, right? This is some sort of registry. This could be anywhere, really. And it has all of these ways, right? So you can do TensorFlow, you can do Onyx, you can do custom. So these are the ones that are specifically of interest to us, right? We want to know how. So with TensorFlow, right? There's TF serving, right, which is the way that you would serve TensorFlow models. Let's see. Typically, the way that you would serve TensorFlow models. And because when we train image classification models with ML.NET, it provides us with a TensorFlow model. We could, like, if somebody said, like, okay, well, hey, like, I want to work with ML.NET and I want to build my models with ML.NET, but then for serving, it's like, hey, I want to do this inside of a TensorFlow serving or service. You could probably do that. Let's see here. Oh, this was it. KF serving, inference service, flower sample configured. Yeah, so it kind of shows you how to do this. Cool. Are we still? It's taking forever. Let's see. What is this explainability component? Okay, it's using ImageNet. Yes. What? You're kidding. There's 27. All right, hold on. Let me see here. So KF serving did explain to the black explainer algorithms images version alibi open source library. Huh. I hadn't heard of alibi. Algorithms monitoring explaining machine learning models. Alibi is for Python ME machine learning model. Okay. Fine. Installation, supported methods, model explanations, model confidence. Okay. My question is, okay, so if we do the iris data set, could I pass in data? Load and prepare the data set, fit regression model, calculate prediction probability. Okay, logistic regression. So you pass in the classifier, and then what it does is it plots for explaining the feature effects towards the unnormalized logit scores. Okay. Okay, let's see. Which means that for instances of pedal rank around 3, the feature effect on the is the same average of feature effect. Okay. Virginica. Interesting. Now, because you need to pass in a a transformer, we couldn't pass in ML.NET transformers, which is unfortunate. Let's see. Alibi API. That's cool. So in this example for ImageNet, what it's doing is, how does it know that it's what is it? A Persian cat? The way it's able to determine it is by its eye, which makes sense. I think it makes sense. All right, so we got our operator pods going. It's almost there. I hope. Teach, learn, Raspberry Pi. No. Docker registry. What is this for? Okay, so add options in order to configurable, define serving signatures from auto serving. Yeah, so there's a lot of components here. I don't know, like, I don't know which ones we're gonna get to leverage, but we'll try to do as many as we can. That's for sure. Okay, this is the image. So Minio, Minio is Minio or Istio? Istio is the control plane. Minio, I think, is the storage. Let's see, Min.io. Yeah, storage. There you go. Min.io. Okay, so Kubernetes. All right, and what were they using Min.io here for? I guess it's just providing a use TensorFlow image as a base image custom Docker file. So I'm guessing this is just to like know where. Store model in our results. Okay. So in this case, Min.io is what's being used for artifact storage. Okay, nice to know. But then what's backing MinIO? Like what? I'm gonna assume that this has already been pre-configured, probably in this notebook setup. Oh no, there it is. It's an S3 endpoint. So let's see, MinIO client. It's an object storage server. Let's see, MinIO provides a modern, okay, supports Amazon and file systems and Amazon S3. Okay. So in this case, I think if we're going to be using MinIO for our artifact storage, we might have to limit it to file systems, which is fine. All right, there's still 23 remaining pods. All right, so to save you from sort of sitting here with me while the remaining pods are up, let's just assume that this is going to deploy. And if anything, I'll try to get it. If something goes wrong, I'll try to debug it and get it working. That way, for Wednesday stream, we're ready to sort of hit the ground running once we set up our server, our notebook server. So yeah, apologize that it actually wasn't faster than I expected. I mean, I know that these things typically take time, um, but yeah, this is yeah. We've been here for quite a few minutes, and this piece was pretty easy, right? Just adding these commands, that was the easy part. Um, but it seems like it's definitely going to take a little bit longer than we would have hoped for. So, yeah, yeah, absolutely. But yeah, no, thank you for joining, and I hope that yeah, I hope that you're excited as I am about this new project and learning about Kubernetes and Kubeflow and all the microservices slash distributed machine learning, all the buzzwords. And yeah, so I'll be back on Wednesday, and we're gonna try to set up a notebook server so that we can run .NET Interactive inside of Kubeflow. Until then, I'll talk to you then.